In question 6, part A, we have to find the values of the constant m for which the line y equals to mx is a tangent to the curve y equals to 2x square minus 4x plus 8. Now, whenever we have an unknown constant and a quadratic equation is involved, we will be using the discriminant, which is b squared minus 4ac. And as it is a tangent, it means there is only one point of intersection. So b squared minus 4ac will be equals to 0. So in the first step, we will equate the two equations. So we'll equate 2x square minus 4x plus 8 is equals to mx. Bring the mx on the left hand side, we'll get 2x squared minus 4x minus mx plus 8 equals to 0. So the value of a is 2. Taking plus x common, we'll get the value of b as minus 4 minus m plus 8. So we can write a is equals to 2, b is equals to minus 4 minus m, and c is equals to positive 8. Now applying b squared minus 4ac, we'll get minus 4 minus m whole squared minus 4 times 2 times 8 equals to 0. Expanding this, we'll get 16 plus 8m plus m squared minus, so this will be 4 2s are 8, 8 8s are 64 equals to 0. Simplifying this equation, we'll get m squared plus 8m, and 16 minus 64 will be negative 48 equals to 0. We'll use our calculators to factorize this, or we can use middle term breaking. So this will become 12m minus 4m minus 48 equals to 0. Taking m common, we'll get m plus 12. Taking 4 common from here, we'll get m plus 12. So the two values of m will be, so this is m plus 12. So m plus 12 into m minus 4 equals to 0. So m plus 12 equals to 0, which means one of the values of m will be negative 12, and m minus 4 equals to 0 means one of the values of m will be positive 4. Now in part B, we have a function which is defined by f of x is equals to x squared plus ax plus b. The solutions of the equation f of x equals to 0 are x equals to 1 and x equals to 9. Now this basically means that when we put x equals to 1, the f of x will be 0. So let's first substitute x equals to 1 into the equation. We'll get 1 plus a plus b, and that is equals to 0. So the first equation will be a plus b is equals to minus 1. Now substituting x equals to 9, we'll get 9 squared plus 9a plus b, and that will also be equals to 0. Simplifying this, we'll get 9a plus b is equals to minus 81. So this was the first equation, and this was the second equation. As in the first part, we have to find the values of a and b. We'll solve the two equations simultaneously. So solving a plus b equals to minus 1 and 9a plus b equals to minus 81. You can first multiply this equation by minus 1 to make the b's of opposite sign, and this minus will become a plus. So b and minus b will cancel out. 9a minus a will become 8a, and minus 81 plus 1 will become minus 80. So the value of a will be minus 10. To find the value of b, we'll substitute the value of a into either one of the two equations. As a plus b minus 1 is a simpler equation, I will use this one. So substituting a equals to minus 10 plus b equals to minus 1. This will become b is equals to minus 1 plus 10. So the value of b will be equals to 9. In part 2, we have to find the coordinates of the vertex of the curve y equals to f of x. Now, as f of x is a quadratic function, we know that it is of this form. As x squared is positive, so it will have a minimum point. The coordinates of vertex mean we have to find the coordinates of the stationary point or the curve or the line which basically divides the curve into two equal parts. Now, an easier way to approach this is to just differentiate the equation and put it equals to 0 to get the value of x. As we already have the values of a and b, and the equation was x squared plus ax plus b, so we can write f of x will be is equals to x squared plus ax. So a is minus 10. This will become minus 10x plus 9. Now to get these points, we'll substitute f of x equals to 0. So this will become x squared minus 10x plus 9. So f of x is not 0. We'll first differentiate it and then put it equals to 0. So differentiating f of x, we'll get dy by dx is equals to 2x minus 10. Now putting dy by dx equals to 0, we'll get 0 is equals to 2x minus 10 and x is equals to 10 upon 2, which is 5. Once we have the value of x, we can substitute this in the function f of x. So this will become 5 squared minus 10 into 5 plus 9. The final answer will be 25 minus 50 plus 9, which is equals to minus 16. We can also use the completing the square method to find the turning point, or we can use the differentiation method, which we have used over here. So in either of these two methods will work if we do it correctly. And if we had completed the square form, we would have gotten the coordinates 5 and minus 16 for our turning points.